Okay, here we go. So let's start with our objective, okay? This is theoretical and experimental probability, okay? And what we're going to do, our objective here, okay, this is theoretical and experimental probability. Okay, and our objective is to determine and compare experimental probability to theoretical probability. Okay, this is 2, 24, 22. Okay. Did you know today is a palindrome also?
This entire week is.
2, 2, 4, 2, 2, and then read it backwards. 2, 2, 4, 2, 2. It's going to happen again tomorrow. Okay.
Wait, how's it gonna happen tomorrow?
Because it'll be 2, 2, 5, 2, 2. 2, 2, 5, 2, 2. 2, 2, 5, 2, 2.
He looks so amazed.
Look. Okay, we have until 11:05. All right, we got to get cooking here. Here we go.
Wait, don't.
So let's start with what is
We only have 20
theoretical
minutes.
and what is experimental probability. Okay, first of all, theoretical probability, write this down for your definition. Theoretical probability is what is supposed to happen. Bless you. What is supposed to happen?
That's theoretical?
Theoretical. What is supposed to happen? Okay?
Well, I thought it was what's supposed to happen.
Very good. What is supposed to happen? Okay? Now, if I flip a coin, okay, no matter what, every time I flip a coin, what is the probability that I'm going to get tails? 50%. 1 out of 2, right?
Yep.
Right? That is what's supposed to happen. If I roll a number cube that has 6 sides, what's the probability I'm going to get a 2? How many 2s are there?
1 and 6.
1 out of 6. If I roll a 20-sided number cube, what's the probability I'm going to get a 5? How many 5s are there? 1 out of 20. Okay, you understand that, right?
Yeah.
Yes.
Okay. Now, experimental probability. Ready? Based on results. Based on results.
Is that all we need to write for that one?
Yep. It's based on results, okay?
Exam?
So let's look at our example. I know that one's kind of small, okay, but if we look at this first example together, right here, okay, the graph shows the results of an experiment. Okay, so automatically we know, is this theoretical or is this experimental? It's experimental, okay? This graph shows the results of an experiment in which a number cube was rolled 100 times. Find the experimental probability of rolling a 3. Now, before we do that, and I already have it here, okay, but before we do that, what is the theoretical probability of getting a 3 on a number cube? Theoretical
1 6.
was 1 out of 6, right? Right? Right?
Yeah.
Okay. Well, based on this result, okay, how many 3s did we get?
16.
16 out of 100, which we can reduce to what?
4 20.
4 out of 25, okay? It's also a 16% chance, okay? Now, it's actually pretty close to what this would be, okay, but not exactly, okay? What if I said, what is the probability that, based on the results, what is the probability of getting a 5? And this is based on results, based on experimental probability. How many 5s did I roll here?
21.
21 out of what? 100. If I wrote that as a percent, what would that be? 21%. So according to this, according to experimental probability, I have the greatest chance of rolling a what?
A 5.
A 5, right? What do I have the least chance of rolling?
A 2.
A 2, because only 13 out of the 100. Now, are those a little bit different than theoretical probability? A little bit different. This is almost 1 out of 5. The theoretical is 1 out of 6, right? Now, if I said this, you have a problem. If I said, if I roll a 5, you win $100. Okay? And I said, and I'm going to tell you at Casino of Kersey that every time I roll a 5 more than any other number. Is that true?
Yes. Yeah.
It's true if I'm basing it on what?
The experiment.
That. Is it true according to theoretical?
No.
No.
In your mind, yes.
Okay? So if I did this experiment 100 more times, do you think they would be the exact same thing?
No.
They could, though, couldn't they? They could, but do you think, put the chair down. Do you think it would be? Okay, all right. Let's look at, do you understand what we just did now? Let's look at the next example. Teeter, put your chair down. Okay. All right, so for exercises 1 through 3, the graph of a survey of 150 students was asked whether they prefer dogs or cats. Okay, this is a simple one, right? It should be, what's the theoretical probability somebody's going to pick a cat?
18.
Okay, listen to what I just said. Listen to what I said. Listen to what I said before you blurt out incorrect answers. Listen. If I asked a person, what is the probability that they would choose a cat?
18 out of 150.
Listen to what I just said. What is the theoretical probability that they would choose cat? 1 out of 2, 50%. What is the theoretical probability they would choose dog? 1 out of 2, because there are only 2 results, and they're going to pick one or the other, right? But according to this, what is the probability of a student preferring dogs?
132 over 100.
So number 1 would be 132 out of 150. Okay? Now we could reduce that. What could we reduce that to? Anybody? Well, let's start with 2's. This would be 75. What's 132 divided by 2?
Might take a little bit to pass it.
Chase?
16 over 75?
Not quite. 66 over 75. Okay, good. All right. You should understand where that came from?
Yeah.
Now look at number 2. Suppose 100 students were surveyed. How many would we expect to prefer dogs? Now, this we have to take a little bit of a different approach on. Okay? Because what we know is 132 out of 150, this is how many chose dogs, and this is the total, right? Right?
Yeah.
Now, if they're asking how many out, if we lower this total to 100, okay, if we lower this down to this, how are we going to find this?
Take that off. Thank you.
This looks familiar. Do you guys remember doing this? What are these called? Chase? Rhymes with proportions. Proportions. And do you remember how to solve a proportion? Rhymes with squash products. Cross products. You remember that? So with your calculators, I'm going to replace this with an X, and I'm going to multiply 132 times 100, and that gives me that. And I'm going to multiply 150 times X, which is this. Then I divide each side by 150, and tell me, somebody with a calculator, tell me what you got. What'd you get, Chase?
88.
88. So we would expect to get 88 people to choose dogs if we interviewed 100 of them.
Mr. Kershaw, I don't get it.
Yeah, I get it.
It's hard.
Yeah.
Wouldn't you have to take some away from the cat too?
Oh, it would, but they're not asking about cats. They're only asking about dogs. Okay? Let's look at another one. Okay? Let's look at number 3. We're going to set number 3 up the exact same way. Okay? This was number 1. This was number 2. Jeremy, you should write this on your skeleton notes. It's really helpful. Okay, look, number 3. Hold on a second, Abby. Okay, if this says, suppose 300 students were surveyed. Okay, how many would we expect to prefer cats? Well, the first thing, if this is based on experimental probability, we need to know how many of these 150 chose cats, which is what?
18.
18 out of 150. Do you understand this is cats and this is the total, right?
Yes.
Right? And we want to know this says out of how many? This says out of what?
3,000.
300. Is that 300 going to go up here or down here? It's going to go on the bottom. So this is 300 total. And this is going to be this number of cats. Well, you can do cross products here, but there's an easier way to do this one. Okay? Because I know that I can multiply 150 times something to get 300. What can I multiply 150 times? 2. And if I do the same thing on the top, what is 18 times 2? 36. So I would expect 36 of those to be cats. Okay?
Mr. Percy, how do you know that this isn't theoretical? Because it doesn't say like.
Well, it says it's based on a survey of 150 students.
I see now.
Okay. Abby, what's your question?
Well, so if you remove, so let's say like on that one it's 150. If you remove 50 from that and then 50 from the top, you can get 88.
If you do subtraction, it wouldn't work that way.
Yeah, it would.
If you took
50 minus 50, or 132 is 88.
132 minus 50,
No, the other way. No. Yeah, that way. And then 132 minus 50 is 88. So you can just do that.
That's not 88.
It would be 88.
okay, let's do this real quick. What's 2 minus 0?
2.
What's 13 minus 5?
7. 8.
That's 82.
What if you
Okay.
add
Oh
a
my
6?
goodness.
Oh, if you just add a 6, yeah.
Then you
Just
add
add a
the
6 to anything.
You add the 1.
I love what you're thinking, and I love how you're thinking outside the box, but it doesn't work. Okay? All right, let's look at the last example real quick. Okay? You guys kind of understand what's going on?
Yeah.
Let's take a look at this. Okay?
A little.
This one says, in a telephone poll, 225 people were asked for whom they plan to vote in the race for mayor. What is the experimental probability of Juarez being elected? Okay? Well, if we look up here, if we're going to find this experimental probability, what do we need to do with these? What do we need to figure out? How many what? How many people voted? So if you add up 75 plus 67 plus 83, what do we get?
224.
But did we already know that?
No.
What does it say right here?
225.
Okay.
Oh, yeah.
So out of 225, how many voted for Juarez? 75. Now, you can actually reduce this, but I'm not really crazy concerned about that. Okay, so this says down here, suppose 5,700 people voted, how many can we expect to vote for Juarez? Well, what do we already know about Juarez?
75 people.
That's 75 out of what?
225.
225 voted for, this is Juarez, and this is total. And what is our question asking us?
How many people?
Suppose how many people voted?
5,700.
So that 5,700, where's that going to go? Up here
No.
or down here? They want to know how many voted for Juarez, right? So this would be 5,700. So how do you think we're going to solve this one? Come on, say it together. 1, 2, 3.
1, 2.
Okay,
Cross
big
products.
cross products. Find your cross products. So we're going to do 75 times 5,700.
Holy crap.
Let's not say that word.
I mean, holy goodness.
Crap is not holy.
Can't be if it's Jesus.
Let's stop right now. 427,500, and the x times 225 is what? Now, how do we solve this? Divide each side by what? By what? By 225. And what did we get?
1,900.
1,900 people voted for Juarez. Okay, do you see how we got that? This is actually not that difficult, is it? Especially because you know how to use proportions. Brayden, will you scoot your desk back, please?
What? Yeah.
Okay. All right. Are we good on this?
No, 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 no.
Okay, I'm going to pass out your worksheets.
Yay!
Okay, there are 9 problems on the front, there are 6 problems on the back. The back side, are you listening to me? The back side is extra credit. You are only doing numbers 1 through 9. You understand? Okay? You can use calculators. Show your work. Lily's going to pass these out for me.
Good job.
I'm just adding by 3.
And I apologize because I had to go fast, but hopefully you understood.